Hello everyone, welcome to another video with Rahul. Today we are going to discuss what an Amazon VPC is. I will give you an overview and then we'll do a step-by-step demo. Okay, so I've created a VPC design. It's a basic VPC design which will help you understand what an VPC does, and we'll create all these components shown in the design. So the first thing is, what does a VPC mean? So if you typically see in an on-premise side, each enterprise would have their own data center. But how does an AWS operate? So AWS has a region. Then within that region, you will have multiple availability zone. Availability zone is nothing but one data center where you will have multiple customers, resources that will be hosted. So how does AWS ensure that there is logical isolation, not physical isolation? Physical isolation would not be possible. So how do you make sure that you logically isolate the resources of each of the customers? That's where VPC comes into play. So it's basically logical isolation of resources for each customer. So when you create a VPC, you create your logical isolation. Now within a VPC, you can create a public subnet and a private subnet. So public subnet basically means if your resources have a route to the internet, then it's a public subnet. Private subnet means resources which will not have a route directly to the internet. They can through NAT gateway, but not directly. The third component we have is Internet Gateway. Internet Gateway is a highly available service from AWS, which allows traffic within the VPC to be routed to the internet. It also does a network address translation, some of the other things. Then we look at the route table. So every VPC comes with a default main route table. What route table does is it basically routes the traffic within the VPC resources, and it can also help route traffic to the internet through the internet gateway. So what we'll do is we'll create two custom route tables and attach one to public subnet and private subnet, and then do some traffic routing. Then finally we have the EIP. So assume that you have a web server hosted on an EC2 instance and your external users are using that web server. But now say an EC2 instance fails. Once it fails, then that public IP it has will be lost. So what you want to do is you want to have an elastic IP, which is basically a static public IP that you can attach to any EC2 instance or a resource. Then finally we'll create the NAT gateway. So how NAT gateway helps us is I discussed that in a private subnet, if you have some resources, they cannot directly talk to the internet using the internet gateway. So how NAT gateway helps is, say in this scenario, you have the EC2 instance, it can talk to then it can route its traffic to the NAT gateway, and then NAT gateway can route traffic to the internet via the internet gateway. Okay. So let me just go to the next slide and show you what are the resources that we are going to create. So we are going to create a demo VPC, a subnet, two subnets, public and private, internet gateway, route table, elastic IP, NAT gateway, and then update the private route table. So let me go to my VPC. So create a VPC. So let me just copy it here in the name. So we are going to, okay, I cannot copy it. So I'll create a demo VPC. So I will give it a CIDR block of n.16. So basically what this does is it gives you an IP range. So you can have the biggest as /16. /16 means that it is going to have about 65,000 IPs. Now say the smallest that you can do is 32. So this will give you one IP. So how you basically calculate what CIDR block you need? First you determine how many IPs you need within that VPC. How many resources would need IP, and then you get an idea of what your CIDR range would look like. Then there are 5 IPs out of whatever CIDR range you pick, 5 would be reserved by AWS, so you cannot use them. Now suppose I want create the smallest VPC, which will be this 10.32. So just assume whatever slash say 32 or 16 you give here, you take 32 as base and then subtract. So you do 32 minus here you have 32, 32 minus 32, 2 raised power 0, 2 raised power 0 will be 1. So you will have 1 IP. But that's not possible because you need at least 5 IPs, which will be reserved by AWS. Now say you pick it as 30 slash 30. So slash 30 means it will be 2 raised power 2, that is 4 IP. So you will have 4 IP. Similarly, if you pick 16, so you do 32 minus 16, 2 raised power 6, which is 65,000. Okay. Now I have selected the site range here. So tenancy means whether you need a dedicated server or you need a default. Most of the time it's going to be default. Okay. So I've created my, you can see now my VPC is up and running. Now what I'll do is I'll go to the subnet. I'll create a subnet. I need to select the my VPC, so which was the demo VPC which we just created. So let me call it public subnet 01. So you can pick any availability zone. Again, you need to pick the CIDR block, but the CIDR block has to be within the range of the VPC. So I'll pick here. So I pick like a smaller CIDR blocks 24. So 24 will be 32 minus 24, which is 8, 2 raised power 8. 8 2 raised power 8 is 16, 256. 256. So we'll get 256 IPs. Okay, let me now create a private subnet. Okay, create subnet. Select my demo. Okay, so I will call it private subnet. I don't matter, that doesn't matter on the availability zone. So I'll create a CIDR block. So you can see here the CIDR block I have chosen 10.0.10/24. So it should not be overlapping. If these two overlap, it will not let you create. Like let me just create. Say if I create the same one, see it will not work. So it will give an overlap because we have already created one with the same IP range. So it has to be unique, but and within the VPC range. Okay. So I created the private subnet. Okay, now you can see we have the private subnet. Okay, so now we're going to create the third thing we are going to do is create the internet gateway. We go to internet gateway. So we create an internet gateway. Let's call it internet gateway demo VPC. I copy it from the name from here. I'm just copying so that it saves us some time. So you create the internet gateway. Okay, so internet gateway. So you can just attach it to the VPC. Now we have the demo VPC. Attach internet gateway. Okay, it's now showing internet gateway attached. And this is the demo VPC that this internet gateway has been attached to. Okay, now the next thing we're going to go and do is we're going to go to the route tables. So we go to the route tables and let me just filter it by demo VPC. Okay, now I have searched it by the demo VPC. So you can see the details here. So we have this route table. The VPC is demo VPC. This is the main route table. Yes. Okay. Now we're going to create a route table. So we'll call it just public. Okay, I'm not able to copy it. So for down public route table. Okay, select the VPC. Okay, 01. Okay, so I create the route table here. Now I have a route table which has the default destination as my destination as the VPC CIDR range and the target is local. So I have to now do an asset. So I do edit subnation and this was the public subnet. So this was the public route table. So I'll attach the public subnet, save station. Okay. Now I was telling you that you need to have an internet route for this particular public subnet. So that's what we are going to create. So I create edit. So I add a route. So internet route would be 0.0.0/0. And what will be the target? The target here would be internet gateway. So I go to internet gateway. Okay, excellent. Do a save change. Okay. Now you can see I have two routes. One any traffic that's within within the VPC CIDR will be local, and if it's internet, then I have to go and do it to the internet gateway. Now let me go to the route table again. I'll create another route table. It will be called private route table 01. I'll select the same VPC. Okay, create route table. So I have the route table now. Again, it has the same default route. So what I'll do is I'll create the subnet association, edit subnet. I have to now attach it to the private subnet. Okay. So here is the private subnet. I do save association. Now you can see that it's been associated with the private subnet. Okay. Now the next thing we are going to do is we are going to create an elastic IP and NAT gateway. So let's create an elastic IP. Here we have an elastic IP. Okay, allocate elastic IP. Allocate. Okay, now we've created an elastic IP, you see here. And I'll go to now the next thing we're going to do is we're going to create a NAT gateway. Okay, so create NAT gateway. So this is private NAT gateway subnet. Okay, so one thing you have to make sure is that you have to create that NAT gateway in the public subnet. So you see here, you cannot create this NAT gateway in the private subnet. You have to create it in the public subnet. Okay, so connectivity is public, elastic IP. So it asks elastic IP. So we already created that elastic IP, and I create a NAT gateway. Okay, so now the last thing we have to do is we have to update the private route table so that any traffic that is bound for internet, so you see here, it should be routed to NAT gateway. Okay, so now I go to my route tables. Okay, and I go to private route table. I edit the routes. I should be able to see the NAT gateway. So when I do 000, I should be able to see the NAT. Okay, you see the private NAT gateway that we created. So make the change. Okay, I think that's about it for all the components. Now what we can do is we can create an EC2 instance within the same VPC, and it should be up and running. So in the next video, I'll show you how to create an EC2 instance within this demo VPC. One thing I just want to highlight is that please delete this NAT gateway because there is a per hour charge. Every hour that you have the NAT gate, you'll be charged some dollars. The second thing is also EAP. Unless if EAP is allocated some resource, then there is no charge. But if it is not allocated, then there will be a charge. And the reason is that they want to save the as much as possible. They want to save the public IPs. Okay. Hope you like the video. Thank you very much.